CANINP and CANOUT are two basic second-generation Merg C-bus modules designed by a Merg member, Pete Brownlow. They are able to be configured simply using the onboard switches, making them ideal for beginners to learn about and experiment with C-bus. Yet they can also be used as part of a much more complex model railway control network. This video is intended to show how these two modules can be configured just using the onboard switches. For more information about C-bus and layout control, download the free ebook from the Merg website. Here is my experimentation board with the two modules connected to the bus. There's an RJ22 expansion connector with bus terminating resistor and a CAN gizmo in bus monitoring mode. And then there's connectors for the 12-volt DC power supply. From the experimenter's kit, I have a board with 8 switches attached to the inputs of the CANINP and a board with 8 LEDs attached to the outputs of the CANOUT. I start by connecting the 12-volt DC regulated power supply and plugging it in. The red power LEDs on the modules light up. The green LEDs also light up, showing that the module firmware is running and the modules are in slim configuration mode, ready for configuration using the onboard switches. With all the onboard switches initially set to off, the CANINP does not actually need configuring. However, it can be configured to use a different node number, which may be necessary if other modules are present on the network. Switches 1, 2, 3 and 4 represent a binary node number between 1 and 16. With all the switches in the off position, the node number is set to 16. If I set switch 1 to the on position and remove and reapply the power, the node number will now be 15. Do not alter the switch positions, otherwise the node number will change when the module is next powered up. The CANOUT module does need to be configured, as it has to be taught what actions should be taken when certain events are seen on the C-bus network. Switches 1, 2 and 3 represent the binary output number from 1 to 8. With all these switches in the off position, output number 8 is indicated. I will start by configuring output number 1 of the CANOUT module. This is selected when all the 3 switches are in the on position. I also turn the Learn switch, labelled L on the PCB, to the on position. The next event seen by the CANOUT module will be learnt. I will use the input number 3 of the CANINP for this, so I turn the connected switch on. The CANOUT configuration switches can now be switched off again. Now, when I turn on the switch connected to input number 3 on the CANINP, LED number 1 will light up. When I switch it off again, LED 1 is extinguished. Next, I will configure output number 7 on the CANOUT module to be operated by input number 2 of the CANINP. Output number 7 is selected on the 3 switches, and I turn the Learn switch to on again. I can now turn the switch connected to CANINP input number 2 to on. Then the CANOUT configuration switches can be switched off again. I also want to configure output number 8 to operate from the same input, number 2. I select output 8 and turn the Learn switch on again. I turn on inputs 2 again, and the CANOUT configuration switches can be switched off again. Now when I operate input switch number 2, both LEDs 7 and 8 light up at the same time and go out at the same time. I also want input number 1 to switch on LED 7, so I configure this in the same way. Output number 7 is selected on the selection switches, Learn is set, and input switch 1 is turned on. Then the configuration switch is turned off again. However, I also want output 5 to operate with input number 1, but as the inverse of output number 7. Output number 5 is set up on the selection switches, and the learn switch is set, but the polarity switch, labelled P on the PCB, is also switched on. I turn on input 1 again, and the CANout configuration switches can all be switched off again. Now when I operate switch 1, LED 7 will light up while the switch 1 is on, and LED 5 will light up while switch 1 is off. Meanwhile, switch 2 will still operate outputs 7 and 8 together. Further configuration can produce all sorts of combinations of outputs in response to the various inputs, and this is left to your imagination. You can erase all the learned events from the CANout, switch the unlearn switch labelled U on the PCB to on, and then cycle the power. Don't forget to switch the unlearn switch off again. You can now start configuring all over again. It is possible to configure the CANINP so that it only produces on events. These can be useful for route setting. Alternatively, you can configure CANINP to operate in toggle mode. This is useful if push button switches are attached to the inputs. One push produces an on event, and the next push produces the off event, and so on. Even more configuration is possible by connecting a computer and using the FLIM configuration mode, but that is beyond the scope of this video. For more information, check out the Merg website.